In this video, we proved that the fraction 21n plus 4 divided by 14n plus 3 is irreducible for every natural number n. This question was the first question in the International Mathematical Olympiad. It was held in 1959 in Romania. Let's do this question. Of course, we can do it using Euclidean algorithm, but we will follow such an approach that even common men can understand. Let's do it. So what do you mean by irreducible number? To understand what do you mean by irreducible number, let's look at the fraction 6 by 8. We can cancel it out and write it as 3 by 4. That's in the least form, right? Let's look at the another fraction 15 by 51. Again we can cancel by 3 and we can write it as 5 by 17. And we say that 5 by 17 is in the least form. And 3 by 4 is also in the least form. So these numbers 3 by 4, they are irreducible because you can't cancel it further. So does 5 by 17. So they are again irreducible. So what do you mean by irreducible? We don't have any common factor to the numerator and denominator other than plus 1. So the only positive common factor of the numerator and denominator is plus 1. Let's prove it. That 21n plus 4 divided by 14n plus 3 is irreducible. Let d be the common divisor of 21n plus 4 and 14n plus 3. Does such a common divisor exist? Answer is yes. D can be equal to 1. Now 6 is a multiple of 2, 8 is also a multiple of 2, then their difference is also a multiple of 2, their sum is also a multiple of 2. That much is enough for proving this result. So 21n plus 4, 14n plus 3 are multiple of d, so their difference should be multiple of d. This implies 21n plus 4 minus 14n plus 3 is a multiple of d. That is 21 minus 14 is 7. 7n plus 1 is a multiple of d. So what is the conclusion? 21n plus 4, 7n plus 1 are multiple of d. Okay, if these two are multiple of d, then their difference has to be multiple of d. So 21n plus 4 minus 7n plus 1, their difference is a multiple of d. Again minus 7n plus 1, you can subtract it and still it will be multiple of d. Again minus 7n plus 1 is a multiple of d. How much is 7 plus 7 plus 7? That's 21. So 21n will get cancelled. 4 minus 1 is 3. 3 minus 1 is 2. 2 minus 1 is 1. That is 1 is a multiple of d. What are the integers such that 1 is a multiple of d? This implies d has to be, if it is positive, it has to be plus 1. If it is negative, it can be minus 1. That's the only possible. So if we have a common divisor of 21n plus 4 and 14n plus 3, that common divisor has to be plus 1 or minus 1. And we conclude that 21n plus 4 divided by 14n plus 3 is